So in this video, we're going to look at why is sine theta the y coordinate and why is cos theta the x coordinate. So first of all, we have to understand this diagram. I think explains a lot in the words. So if you've got an angle, let's just say this angle here, which is theta, okay? We have this point here. Now let's talk about the unit circle. We call it a unit circle because it has a radius of 1. That's the first thing we've got to do. And we use this just as a teaching tool. I mean, you could extrapolate it out to 2 or whatever, but let's look at this. If we've got this as a radius of 1, that means that this length here is 1, right? I mean, that's what we're trying to do. Now we're trying to find out what this coordinate is there. Now let's first think about this. Well, that coordinate here, don't forget, we're talking about a Cartesian plane. So this is really 0, 0, right? Okay, so we've got 0, 0. So this coordinate here is whatever on the x and whatever on the y, right? So what we can talk about is, I know that, well, the x coordinate is how far we've gone across left to right. Now, how do I know what that is? Well, just say if I told you that this angle was 30 degrees, right? And if I said that that had a radius of 1 or a hypotenuse of 1, and this obviously makes a right angle triangle because you can see that this makes a right angle triangle. All right, so let's just take that all back. If we're looking at that, we're really just trying to find out what this length is, because if we can find out what this length is, we know how far we are left to right from the origin, which would be really the x coordinate, right? Like it would tell us really what the first coordinate is. Okay, because if we move up or down, obviously, then that's the y coordinate. So we want to find out how far up we've gone. So how far across have we gone? Well, if we've got a radius of 1 and we also have a right angle triangle here, well, we know that, and let's just take the triangle out just to make this a bit easier to understand. So we've got this right angle triangle. Yes, I know it doesn't look right angle, but it's pretty funky. And this has a hypotenuse of 1. And if I gave you the angle here, and let's just say, I know I said 30 before, let's say it's 60. Well, what's this length? Well, what ratio would you use? Well, you know that this is the opposite, right? And this is the adjacent, and this is the hypotenuse. Okay. However, in this case, the hypotenuse is 1. So let's look at this. You'd use cos, right? You'd use adjacent cos theta equals adjacent over hypotenuse. In this case, though, the hypotenuse is what? The hypotenuse is 1, so the denominator's 1. Now, any number over 1 is just that number itself. So in this case, we can say that cos theta equals the adjacent. So cos theta just equals the adjacent. Therefore, if I do cos of 60, that length will be the adjacent. That is that length. So it's going to tell me how long it is, which means that this point tells me the x coordinate. So I know that cos theta is going to give me the length left to right. Similarly, if I want to find out how far up and down I've gone from the origin, which I want to look at, that's opposite over hypotenuse, because I've got 60 degrees and 1. So again, that's just going to be, sine equals opposite over hypotenuse. That's theta. That means it's going to be sine equals opposite over 1. So therefore sine theta will just equal the opposite. Okay, so that means this is sine. So that's for why we can say this is sine theta, why we can say that's cos theta, because it will actually, and we can say that this position here has the coordinates of cos theta, sine theta, which would actually be a number itself. So that would be sine theta here. So how do I remember this? It's an interesting one. So I always try and think of actually this diagram here, but I kind of just draw a little triangle myself. And I think of, well, if the hypotenuse is always 1, well, if I want to know this length, it's going to be adjacent over hypotenuse. So adjacent over hypotenuse is cos. So I know that cos is always going to be my x coordinate, okay, because it's telling me left or right. And if I think of this one in the first quadrant, I always think of it in the first quadrant, well, it's going to be opposite over hypotenuse, and that's sine, okay? Sine opposite over hypotenuse. Now, when you've got this is your opposite, don't forget, and this is your adjacent, we call these lines, and I will get this onto the next video, but why do we call this a tangent line, something like this? Is because if you think about a tangent is TOA, opposite over adjacent. So therefore we could actually say that tan theta is equal to opposite, which is sine theta over cos theta, which should stay true, which is actually what it is. Now we don't need to know this. quite yet anyway. Going back to this one though here, and this concept here, really what you want you to understand is that the coordinates is cos theta and sine theta. I mean, that's the deeper understanding that we want you to know. Also that, you know, if I'm starting here, obviously that's 0 pi here, okay? Now, when you do a full 180 degrees, that's going to be pi, because don't forget there's 2 pi's in a full revolution. So half of it would be 1 pi. That's why I say there's 2 pi in 1 pi. That's like the pie you eat, because it's like a, you know, a meat pie or an apple pie. So we can actually measure the angle in there. So for every pi is 180 degrees, okay? So if I need to change, so if I'm actually trying to, you know, give points, so for example, if I want to know, you know, what cos pi is, you know, here, so if I want to say, well, what's cos pi? Well, cos pi, if you think about it, well, what is cos? Cos, again, is a measurement of the x-coordinate. Well, the x-coordinate over here is -1. So if I said, what's cos pi? That would equal -1. If I said, what is sine pi, though, this is different, because sine is a measurement of the y-coordinate. Well, if you think about it, it goes up to 1 here and down to 0. So sine pi would just be still 0. Now, if I said, well, what's cos pi on 2? Now, cos pi on 2 is a bit different, because if you think about it, that's only half a pi. Well, cos is the x-coordinate. Well, you're at 0, right? So that's still 0. So if I say, well, what's sine pi on 2? Well, sine pi on 2 is going to equal 1, because it goes around here. Now, we can go really big on these. We could also start saying, well, what's cos, you know, 25 pi? Now, that sounds really tricky. Now, some people go, oh, well, 2 pi, 4 pi, 6 pi, 8 pi. That's a long way to go about it, up to 24. You got to think, if I had 24, that's like 12 revolutions, right? So, I mean, you just take it to the nearest one, and then you'll be left with 1 pi, which would just take back to here. So I kind of see it as like, well, 24, I kind of see it as, you know, this is cos 24 pi plus 1 pi. Why do I see it like this? Because I know 24 pi is going to be like, you know, every 2 does a full revolution. So it's just getting me back to the start. It's just done 12 revolutions right around. And then I'm doing the last pi, which means that if it's cos, which is measuring the x, it's still going to be 0, right? So that equals 0. However, if this was sine 25 pi, you know, again, I kind of go, well, I know 24 is going to take me back to the start. So really it's effectively the same thing as saying 1 pi. Sine, cos should be -1. I made a mistake. It's the x-coordinate. Sine 25 pi should equal 0, because that's measuring the y direction. So again, that's going to go over here, and that's going to be 0 there. So you can see how easy it is to get confused between cos and sine, but always just come back to, I think the right angle triangle is quite good. Think of adjacent, adjacent over hypotenuse. Adjacent is here, okay, where sine is opposite over hypotenuse, opposite here. So this is sine, right? This is cos. So that's what I always think. Oh, so that's my x, that's my y coordinate, and that's how I can check what I'm measuring. And then just don't forget, this is your x coordinates, right, left to right. So, I mean, really, I would personally label this as 0, 1. This is -1, 0. I would put these as coordinates, not like this, because it's just confusing, okay? And therefore, you really then can look at it. So, you know, your cos is here, 1, 0 when you're up here. It's -1 when you're there, 0 when you're here, and so on. Later on, we're going to look at exact values of this, so that will be quite interesting. But that's pretty much where we're going with this one. And I suppose the last thing is, you know, I'll just quickly go through, like, if you've got like sine 3 pi on 2, well, that's like a whole pi and a half. So that's like 1 whole pi and a half. So what's sine? Sine's a measurement of my y-axis, so it's going to be -1. If I had cos 3 pi on 2, that's going to be 0. Now, if I also had, say, sine of negative pi on 2, now that's moving in the negative direction this way. So negative moves this way, positive moves here, and we always start from this point here. So if it was negative pi on 2, I just move negative pi. Sine negative pi on 2, well, that's the y coordinate. That's still going to be -1 for that one. Okay, if it was cos negative pi on 2, that would be 0. Notice that sine 3 on pi on 2 is going to be the same thing as cos sine negative pi. So actually, they have a similar relationship there, because they're the same point on the unit circle.